Welcome to this introduction to GitHub. My name is Peter Detender, a lead technical trainer here at Microsoft. I'm excited to walk you through a platform that sits at the center of modern software development and DevOps practices. Whether you're working independently or as part of a distributed engineering team, GitHub is where your code lives, grows, and evolves. It's an entire ecosystem built around helping people like yourself collaborate effectively on software projects. Over the course of this module, I'll help you understand how GitHub brings structure, traceability, and clarity to development workflows, and how it makes teamwork smoother, even when everyone's working asynchronously or across different time zones. My goal is to make this training both practical and empowering, giving you the knowledge and confidence to use GitHub fluently in your daily work. Before we jump into the practical demonstrations, I want to give you a clear picture of what you'll learn throughout this module. GitHub offers a wide variety of capabilities, but at its core are a few fundamental concepts that really shape almost everything you do on the platform. Repositories, branches, commits, pull requests, issues, and discussions. These building blocks form the foundation of teamwork on GitHub, and understanding them well will help you collaborate confidently and efficiently on any project you join. In this module, we'll look at each of these elements in depth, not just from a conceptual standpoint, but through real examples that connect directly to how developers and DevOps engineers like yourself actually work. By the end of today's session, you'll know how to create and manage repositories, how to use branches to isolate your work, how to structure meaningful commits, and how pull requests drive review cycles and code quality. You'll also learn how to navigate GitHub's collaboration features, including issues, notifications, and discussions, which help teams communicate effectively and keep work aligned. My goal is that when you finish this module, not only will you understand GitHub's features, you'll also appreciate the mindset and workflow that makes GitHub such a powerful environment for building software collaboratively. On this slide, I want to set the stage by explaining what GitHub actually is. Many people first encounter GitHub as simply a place where code is getting stored, but it's so much more than that. GitHub is a full development platform built on top of Git, the version control system that tracks changes to your code. GitHub takes those capabilities and layers on powerful collaboration tools. Things like pull requests, issues, discussions, automation workflows, built-in documentation, and even AI-powered features like GitHub Copilot. All of these tools work together to support you through the entire development lifecycle. Planning, writing code, reviewing work, securing your project, and deploying your solutions. One of the key strengths of GitHub is the way it centralizes everything related to a project in one single place. So instead of juggling multiple systems for code, documentation, discussions, and project tracking, GitHub brings these components together so that you always have context and visibility. The conceptual image on the slide here shows the different layers, from collaboration to security and scale, that GitHub provides to help you build better software. As we explore the platform together, you'll start thinking of GitHub not just as a code storage solution, but as this control center for your entire development workflow. So now that you know what GitHub is, let's talk about the heart of any project on the platform, which is called a repository or repo. It's where all your project files live, along with the complete version history. It's also where all your collaboration takes place. Issues, pull requests, documentation, code reviews, and automation all connect back to the same repository. So one of the first decisions to make when creating a repo is the visibility, or better said, it's accessibility. Why? Because we have public and private repos. Public repos are open to everyone on the internet and are super great for open source projects, sharing knowledge and building a portfolio. Private repos, on the other hand, give you full control over who can see and collaborate on your code. Perfect for internal tools and, yes, sensitive projects. Understanding these distinctions help you set up your development environment correctly from the start. So once your repository is created, you're ready to begin structuring your project and inviting others to contribute. Keep in mind that you can always change the visibility of the repo through the repository settings. In a previous module, I discussed and demoed Git source control. Building up on the same concepts, GitHub suggests using GitHub Flow, a simple but incredibly effective workflow leveraging the powers of Git and used by countless software teams. GitHub Flow is centered around the idea of small incremental changes made on dedicated branches. So instead of updating the main branch directly, you create a branch for each new feature, a new fix, or just experimenting. This keeps your work isolated and gives your team a chance to review and discuss changes before they go live. The workflow encourages quick iteration, frequent integration, and a clean codebase. One of the most important components of GitHub Flow is a pull request. A pull request is where you propose merging your branch into the main branch, and it becomes that central hub for code review, conversation, and validation. By using pull requests consistently, teams maintain high code quality, share knowledge, and catch issues early. This workflow supports modern DevOps practices like CI/CD, continuous integration, and continuous delivery, ensuring that your main branch stays stable while development continues rapidly in the background. Now, this next slide walks through each step of GitHub Flow much more in detail. It starts with creating a new branch, which gives you a safe space to build and test changes without impacting the main branch. Branching lets you experiment freely, trying new things, and then refining your work over time. Once your changes are ready, you capture your progress through commits. These are small, meaningful snapshots of your work that document what changed and why it changed. These commits form a timeline over your development process, making it easy to track decisions and troubleshoot later. Then after you've finished working on your branch, you open a pull request to ask your team to review your work. This step is crucial because it really brings collaboration into the workflow, where then your teammates can comment, suggest improvements, point out issues, and then eventually approve the changes when everything looks good. Once the pull request is approved, you merge your changes into the main branch, and that feature becomes part of the live project. This structured process ensures that your main branch remains stable, but also production ready, while still supporting fast and flexible development across the team. Now, pull requests, or PRs as we typically call them, are one of the core collaboration tools in GitHub. A pull request lets you propose changes to a code base, but it also provides a rich space for conversation, documentation, and reviewing. When you open a PR, GitHub shows the differences between your compare branch, where you did all the work, and the base branch, typically again called main or master. This visual comparison makes it easy for reviewers to see exactly what changed and why it changed. Now, what makes pull requests so powerful is the discussion that happens around them. Team members can ask questions, provide feedback, point out edge cases, and suggest improvements. All this keeps code quality high and ensures that everyone understands how the project is evolving. Pull requests also create that permanent record of decisions, as well as discussions, which then becomes invaluable for onboarding new team members or revisiting older work. Once the team is satisfied, the pull request gets approved, and the changes are then getting merged, making the PR a central part of collaborative, high-quality software development. Once the pull request is ready to be merged, GitHub gives you several options for how to integrate your changes. You can create a merge commit, which preserves the full history of your branch. You can squash your commits into a single clean commit, or you can rebase your branch for a linear history. Each option has benefits depending on your team's workflow preferences, and choosing the right one helps keep your project history tidy and understandable. Another important part of this process is writing clear commit messages and selecting the correct Git author information. A good commit message explains why something's changed, not just what changed, which becomes extremely valuable when you revisit code months later. Author metadata helps teams track contributions accurately and maintain clarity across the repository. These small details make your repository history easier to navigate and really strengthen the long-term maintainability of your codebase. So now that you learned the fundamentals, I'm going to bring you into the next live demo that ties everything together. In the demo, I'll show you how to create a repository, start a branch, make commits, open a pull request, and eventually merging it. You'll see the entire GitHub flow in action, from the initial idea all the way through to merging the change back into the main branch. And this is really where the concepts you've learned start feeling real. So I'm switching back to our fantastic DemoCats website that we built in the previous module. And remember that everything we did over there was Git local machine based. We're going to bring this into our GitHub environment. There's a lot of different ways again to do this. I'm going to show you the VS Code approach. So nothing's really changed. You might go like, wait a minute, Peter, you actually made some changes on the file, but that's just like adding more information on my webpage. But basically did the same thing. Where now I again need to commit my changes. I check in my index file. I could check in any of the other files. And then again, made some layout changes in the site page. Where now I'm going to call this commit message ready for production, let's say. I'm going to commit, and that's still happening locally. Where now, again, thanks to the source control integration, we can now interact with GitHub. Now, before this works, you need to authenticate. So in your account options in VS Code, you can see here that I'm obviously pre-authenticated to my GitHub environment. I commit my changes, everything's getting updated locally, and now I want to push this into a GitHub repo. The cool thing here is that I can just publish my branch, and remember, we call this the main branch, which by the way, you can see down here. I'm going to publish, and it's going to ask me, how do you want to publish this? Now, since this is the first time we publish, it means it's going to create a new repo for me. Once we start updating or creating the repo, we still have that interaction, and that's where you got that relationship between your GitHub repo and the Git commit changes, or overall Git operations, I would say. Where now, the first time, I'm going to create a public repo. If you don't really know what the repo is about, I would say go back to the start of the module. But I'm going to use public because it means for now, maybe you want to look into the code. Maybe you like validating what's happening, and I'll walk you through some of those steps as well. So I'm going to select publish to a public repo. And then obviously in a full production, more complete web application, this might take a little bit longer. In my case, it's going pretty fast. I can open up my repo on GitHub, and it's immediately redirecting and opening that location. Before diving into more steps, let me walk you through a few details that you can see here. So first of all, I am pre-authenticated. So this is my Peter account. This is my GitHub account. And underneath, it now created that demo cats repository, which now means inside we have all the code, my index file, my CSS file, and maybe later on we're going to add some more files into it. We also have an identification what the branch is about, and we can also look into the commit history. So I can select commits, and everyone, because again, this is a public repo, everyone who knows about my repo or maybe at some point finds my repo, they basically get access to the full history. And if you look for more open source projects, and we'll talk about open source in another module, you're going to see that typically you're going to have that full history, sometimes a few months back, sometimes multiple years, to just give you as much insights as possible on what happened in that project. So from here, I can clean up HTML as an example. And if you remember from the previous demos, we had just the hello cats, and then we deleted and we made some updates. Like all those changes, the tracing literally, like we emphasized on the Git side, is now embedded, integrated, if you want, into that GitHub platform as well. So now we're going to take it a step further, where we're going to move into branching. Two different ways to do this. You can create a new branch from here. So if you select the branch, since we only have one for now, it's called main branch. And then from here, I can create a new one. So I'm going to call this the demo1 branch. And then refresh my page. It's already doing it for me. It's now showing that I got access to two different branches. The main branch, which is also the default. You'll find out later on when we talk about security in any of the other modules that the default might be important to remember. And then obviously we have the different branches, and my current active branch is the one that I just created. The nice thing is if I move back to my code view, I can now switch between main and my other branch, and you're going to see that all code is exactly the same. So now I can make a change. So let's go in my demo branch. I'm going to open the little browser-based editor. And again, I'm going to remove some information. And yes, you could add. So it's just mimicking a change, but it doesn't matter which change you're making. We need to commit. And we can add a little description here, or using GitHub Copilot, which I'll talk about in the last module in this course. And as you can see, it's just trying to automate little tasks for me. And I'm going to commit directly into this new branch. Now from here, we have two different versions, if you want, of the web application. We still have the main source, but now we have an updated version, a different version than main. And it means that now we need to look into the changes. So if I refresh my code page, GitHub here is going to inform me like, hey, Peter, since you're the owner of the repo, I want to drive your attention to the fact that now we have the main repo and we have this new demo branch repo as well. Typically, one of the tasks for a senior developer, maybe a peer developer, right, is obviously checking out what changes did you make between the main branch and the updated branch. So you can add a description, typically picking up like the same commit message to make it easy. And we're going to create a pull request. You can still look in all the details because again, we triggered a git commit. So I'm going to create a pull request. And then the idea is that I would pull in one of my colleagues, asking them like, hey, can you please validate my work? Can you check the details of the pull request? And then preferably at some point, you're going to add or receive a commit, right, from your colleagues like all good. Nice work, Peter, which is easy if I'm the owner and I'm making all my own changes. And I'm going to comment. And then eventually we can merge the pull request. Where again, the merge means we're going to bring those two changes together. I'm going to confirm. And then from here, the last step is optional. but now you can decide to delete that branch. This is all GitHub browser based, so I'm going to show you quickly the same process, but now triggered again from VS Code. So I'm going to switch to my VS Code. Remember earlier, I showed you down here, you can see your active branch, but now you can, I'll make it a bit bigger. You can see that we have the main branch in my VS Code, and there are 2 changes waiting. So now we have some sort of a conflict, some sort of a difference in versions. And if I want to continue working on the other branch that I created, I can select the branch topic, and it's going to show you that little built-in integrated VS Code view. But now you can see that that other branch, the demo 1 branch we created, is not visible. Why not? Because I need to refresh. And then it's going to apply all the changes, and then it's going to show me my demo branch over here. I can create a new branch from here as well. So I'm going to select create new branch, and I'm going to call this the VS Code branch. This could be a feature branch. This could be an individual person named branch, like the Peter branch, assuming that it's all the work that Peter is doing in this repo will always be saved or stored in that Peter branch. So you can play a bit, and typically that's where you need to talk to the team, like what is the best practice, what is the guidelines, what are the naming conventions, and whatnot. So we're going to create a new VS Code branch, and we're immediately switching from main to VS Code. And from here again, I can make some changes. Where now we're going to do our dear feline friends saving. Source control kicks in. I accept the changes. I'm going to commit, making it more lovely or whatever we want to add into the commit. Try to keep them useful, right? We publish the branch. It's synchronizing, and it tells me here you need to create a pull request. If I switch back to my browser and I'm going to refresh, it's again highlighting like, hey, you need that pull request operation. I could now go back to the browser. I already showed you how to do that. Now, the fact here that I do have this pull request recognition is not just source control anymore. So what I did is go into VS Code extensions, and I added the GitHub extensions into it. And you can see later on, we'll talk about GitHub Copilot. It's there. We have GitHub Copilot for Azure. So just go through that list and install the scenarios that you want to use. You don't have to. It just, because I could say a lot of my work is happening in VS Code, and the less I have to like step out of that interface, moving to the browser, from the browser back to VS Code, and so on, it's just making my life a little bit easier. I guess that's it for this part of the demo. So let's switch back to the presentation. Now, GitHub isn't only for code. It's also a fantastic platform for sharing knowledge across your team and organization. Examples available within GitHub for this is GitHub Wikis and GitHub Pages, 2 features that help you document your projects and make information easier to access. Wikis provide a dedicated space for documentation right inside your repository, supporting Markdown, version control, and collaboration. You can use wikis for everything from architecture diagrams and onboarding guides to troubleshooting steps and operational manuals. GitHub Pages takes this even further by allowing you to publish a static website directly from the repository. So whether you're building internal documentation, a team website, or even a full project homepage, GitHub Pages makes it simple to host content without needing to worry about servers or deployments. You just choose a branch, select a folder, and GitHub handles the rest. Together, these tools help teams centralize knowledge, keep documentation close to code, and ensures everyone has access to accurate, up-to-date information. So I got another demo here, where you'll see how to enable and use wikis and GitHub pages in a real repository. I'll show you how to create and edit wiki pages, organize your content, and use Markdown to make your documentation clear and visually appealing. And then we'll switch to GitHub pages, and I'll walk you through the steps to publish a website directly from your repo. You'll learn how to configure the publishing settings, select a branch or a folder, and upload content that becomes instantly available. I'm going to keep using my DemoCats little demo example for now, and what we want to do is adding a wiki page into it. The starting point, if you remember, is your GitHub account, the repo, and from there we're going to select wiki. Again, that wiki, think of it as like Wikipedia. I'm pretty sure a lot of you are familiar with it. So you're just creating your documentation space. You can argue, do we really need this? Because you also have that README, but I think it's just different in behavior, where the README is considered part of the repo, where the wiki is typically like the place you go to find more documentation, maybe finding a more extensive knowledge base instead of just the highlights in the README file. So we're going to create our first wiki page, and it's called home, which I think is okay. And it's going to add a little bit of a sample sentence in here. We can use Markdown, and I don't want to detail too much about this yet because we have a specific module on Markdown later on, but then I'll just remind you like, hey, remember, this is popping up all over the place in GitHub. So I could add, this is the wiki page for DemoCats, and maybe creating a little header. I want to make it bold to just emphasize, and we're going to save the page. And then from here, it's refreshing and it's nicely showing the content. Respecting that Markdown layout, we have the header over here. I turned it bold and you can see that it's actually nicely showing up. Another option is adding a footer where you could, for example, define a timestamp maybe. So what you could do here is like adding some copyright and then maybe, I don't know, Peter 2026, or a lot more. Again, it's just a layout page, right? And that's going to show up as the footer now. Pretty easy, pretty obvious. There's a lot more you can do with the wiki pages. You can create sidebars. You can create like a little menu view. Obviously, the assumption here is that you have a lot more knowledge that you want to share. Now, the thing with the wiki is that it's really part of that repo. And in this case, it's public. It means that everyone can connect to it. But what if you have a private repo and you still want to expose public information? That's where maybe you're going to look into GitHub pages. And that's the second part that I'm going to show you. There is no tab on top here in the menu for pages, but we need to go to the settings. Out of the repo DemoCats, I go to settings, and over here I select pages. So again, what we're doing with pages is creating a little web application space. And again, my web page is just HTML, so nothing too fancy. But if you have like a static web app platform, like Blazor could be one of them in the .NET family, you could use React or Vue and obviously a lot of other frameworks. It actually allows you to build like really compelling web applications and then using GitHub pages as an actual web server platform. So it's not just about publishing a documentation page, it could actually run full web applications. So what we need is specific settings where I'm going to highlight two of them. First of all, we can create different GitHub page environments for different branches. So like in our case, right, we have the main branch considered production ready, and then we have demo 1 branch and we have the Peter branch. Where now you want to validate, like, I want to see all the changes that happened in the Peter branch, or the VS Code branch, I think we call it. I want to see those pages in a live running environment. So we can define which branch do you want to use. And then from there, we can save the changes. So I'm going to grab my VS Code branch. I'm going to save my changes. And it's going to tell me here that the page is now getting built. Building in GitHub means it's running GitHub Actions. And it's basically CI/CD pipeline, where for this one, it shouldn't take too long. But it's going to test the code, compiling. My example is just HTML, so it's not going to take too long. And then from there, it's going to publish, like the CI part lives over here. And then the CD part, you could say, is now the deploy stage. Build is complete, and deploy typically for this super easy website probably takes like 10 seconds, which now means if I go to that link, it's no longer the repo link, but it's now the name of my GitHub account, github.io, the name of my repo, and it's loading my HTML page. Pretty cool, pretty easy, I would say, to expose information, to share knowledge using Wiki, or maybe more public, more like that real web application experience using GitHub pages. That's all for this part of the demo, so I'll see you back in the presentation. Now from here, we'll take a little turn into searching, an essential skill for navigating large code bases or understanding the history behind the problem. GitHub offers both global search, which looks across all repositories, as well as scoped search, which filters results within a specific project. I'll show you how to search for keywords, file names, even code snippets to uncover discussions, issues, and changes related to your topic. When you're trying to fix a bug or understand the context behind a feature, searching the repository history becomes invaluable. You can quickly find earlier conversations, previous attempts at solving similar problems, and insights shared by other team members. These search capabilities help you investigate effectively and reduce the time spent digging through code manually. Now, the way to do that is, for example, Git Blame and GitHub's enhanced Blame view. Two tools that help you understand how a file has evolved. The Blame view shows you which line was last changed, by whom, and in which commit. This is especially useful when you're trying to understand why a particular line of code exists or when a behavior was introduced. But I also know that the wording is a little bit confusing. It's not about blaming someone. It's about finding the right person to talk to when you need clarity. Another useful search capability is auto-linked references. This is GitHub's way of automatically creating clickable links when you reference issues or pull requests using shorthand. So for example, when you type #42 inside a pull request comment, will automatically create a link to issue 42 in the same repo. This makes cross-referencing work across your repository incredibly quick and intuitive. You can also manually link related issues or pull requests or projects to provide more context and establish relationships between different work items. This obviously is particularly helpful for tracking feature dependencies, documenting conversations, and ensuring that no piece of work gets lost in that shuffle. These linking features help make your repository more cohesive and navigable. So we had another demo here, where I'm going to put our search and history tracking skills into practice. I'll show you how to use GitHub search tools, how to explore commit timelines, how to use Blame to trace changes, and how to jump between related issues and pull requests. So one of the other operations is, like, how can I find information about my own repo, and then obviously why not using the open source model of GitHub to find other informational repos. The first example is using search within your own account, within your own repo. Still the same example here for now. I'm inside my GitHub account. I'm inside my demo cats repo. And from here, I can use search. Now, there's a lot of operations possible here. I'm just going to show you a few of them. So what it does is using the powerful search index using keywords. I'm showing you the repo. So it's again, repo Peter/democats. And what it's going to do is immediately creating a little index of all the files in the repo. You know that my repo is not really impressive, but it allows me to easily navigate to like the index file to my site CSS file. And then later on, we can do the same using Copilot, but I'm going to skip that for now. If I now remove that repo, it's going to give me more information. For example, here, it's going to show me all the repos where I'm an owner of. Obviously, my own repo, and out of the job, out of being a technical trainer at Microsoft, I get access to the Microsoft Learning repo, which is an open source with lab information, and I get access to the Azure repo with Azure documentation. It also keeps track of my most recent, it's not frequently accessed, but most recent repositories that I used. So I could now jump in another repo and it's immediately redirecting. And then from here, we can again do the same search operation. Another example is literally searching for other public repos. So what that means is, for example, here, I'm going to search for .NET, not selecting any of my own .NET repositories, but now it's going to show me all public repos having something to do, being related to the .NET keyword. Let me grab this .NET, that's like the official organization name within GitHub, and underneath we have the ASP.NET Core documentation. And that's immediately bringing me to the one and only official .NET organization, and underneath the official repo with all the ASP.NET information there. One other interesting piece is that we can go back and obviously using the filtering mechanism. I'm not going to show you here like what are all the options, but imagine that you're not just looking for a namespace-based repository, but you want to collaborate. One of the things we'll talk about in the next topic with open source. What if you want to see which issues are available? Are there that maybe you want to contribute to? What if you want to look into existing pull requests within a specific repo, or again, the broader open source? Or what if you want to filter based on any of these development languages? Pretty easy, but super powerful. And again, I'm just showing you a couple of highlights, the ones that I typically use when using the search filter, but you can do a lot more, like really super powerful. The other step that I wanted to show you here is that git blame action. You can do this from the command line. You can do this from within the GitHub environment. So I'll start with GitHub and then showing you what it looks like using git command. So again, git blame or GitHub blame, it's based on the same thing. It's not about blaming the individuals, but it's about finding information linked to commits who actually made the changes. So I'm going to switch back to my democats repo. I open the file, and from here, as I showed you earlier, we have the latest commit message. And now we can also pull up the history. Now that git blame is share more information about the account, the individual, the user, right, who made those changes. There's a couple of different ways to do that. So first of all, and again, this is just my own account because I'm not really collaborating with other peers yet. I can see my latest commit message, but now I could also just move over my commit, and this little pop-up window is the git blame. So it's going to show me how did this change arrive in your environment where it's replicating pull request. It's going to show me the author linked to that commit operation that we did earlier. And then from here, it's also showing the highlight. What were the physical file operations linked to the commit message? So again, pretty easy. It's all there, one single interface. If I switch to my terminal, I'm still in my demo cats folder, where now I can do git blame, and it's going to ask me for some parameters. You remember from before, you can do git help blame. It's going to open the local documentation with a lot more options. So if I do git blame for my index page, as an example, it's now going to pull up all the changes across, I'll try to highlight, across the different commits. So we have a commit A0, we have another commit 9.8, and then another one and yet another one. So you can literally pull up all the changes. Now you can see that there is a little bit of overlap because we got a A0 over here, then we got some changes here. So the way you have to look at it is what's happening on this side. So this is my HTML coding view, you could say, and it's going to show me all the different latest versions of each and every line of code, and again reflecting the different commit messages. So now just having a quick view here, I know that probably the starting point was that A0E5 commit, and then from there we made some changes where, if you remember from previous demos, I added a change in our dear feline friends, where before it was our feline friends, and all those operations can again be traced, can be linked, and that's in short what git blame is doing. Last part I want to show you is that auto-linked feature. Inside my demo cats repo, remember from previous part of the demo, we have a pull request. Now imagine that I want to add comments into my operations. Later on in projects, we'll talk about issues. You can cross-link all that GitHub information. So what that looks like, we have an open pull request. That's the one that you currently see, but nothing blocks me from going back to a closed pull request. So now I have to change my filter from open to closed. I have to go back here, like, oh, what did we do in this PR? And then we can read through all that history. Where now imagine that my closed pull request is basically linked to my new pull request. Then from here, I'm going to add a comment. This code change is identical to, and then I'm going to use that hashtag. And that's now pulling up all existing pull requests. Open ones, closed ones, doesn't matter. And that's one of the fastest way to create your documentation, to update your comments, and having that continuous cross-linking across standalone repos. Within the repo, you have the pull requests, and then later on we have the issues, and it's all based on that little hashtag. And from there, it's going to allow you to bring in that information. Well, now I can link to this one, and then when I save it, you can see that it's now getting refreshed. And inside my commit, it's a lot nicer, cleaner, and it's giving me an immediate short link where I can quickly pull up like what's inside. It's still an open PR. The PR was from my VS Code branch into the main branch, managed by Peter, or I can just open it up completely, and it's immediately redirecting me to that actual item. So super easy. That's in short what the auto-linked feature is about. And I think that's all for this part of the demo. So let's wrap it up on the presentation part. To wrap up the module, let me summarize the key concepts you've learned. You now have a solid understanding of repositories, branches, commits, pull requests, issues, discussions, notifications, and history tracking. These foundational skills enable you to work confidently and productively in GitHub-driven environments. There are many ways to continue your learning journey. I encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn at akms/learn. Thank you. There's still a lot more to talk through. So why not joining me to the next module, where I will talk more about GitHub product plans. I'll see you back in a bit.